In this lesson, we're going to look at domain and range and intercepts, both x and y. So quickly, we will go ahead and define them. First off, we're looking at parent functions. So this is a family of graphs or a group of graphs that display similar characteristics. And we're going to look at three of your parent functions today: linear, quadratic, and cubic. And then as we work through the course, we will look at the others. Okay, a parent function is considered the simplest function of a graph family. Okay, so this is one that hasn't been moved up or down, left or right, hasn't been dilated, hasn't been rotated, hasn't been reflected. It's the simplest of all of the graphs in that family. Okay, the first thing that we're going to look at is domain and range. And remember that your domain is your possible x values. Okay, and your range is your possible, your possible y values. Okay, so we're basically looking along the x-axis or the y-axis to see what are some potential solutions, where would our graph actually end up. Okay, so the first parent function we're going to look at is linear, which means it's going to make a line. The simplest form of this is y equals x, but know that we will be looking at other forms of it. As long as your exponent is 1, this is the key. That's how you know you have a linear function. It's going to look like a straight line. I graphed the basic one here for you. Okay, so as you can see on our graph, the ends, Desmos doesn't draw the arrows for us, but we know that this graph is going to continue both directions to infinity. So our domain is our x values. So we are looking left to right along this x-axis, and we see it's going to continue infinitely to the left as well as infinitely to the right. There's no stopping places. So our domain would be negative infinity to positive infinity. Or you could also say all real numbers, depending on what your options are for the questions you're answering. Okay, range is our y-axis, so we're looking up and down. Okay, positive is up above. And we can see this graph, if it continued on, if we went past the page, it would go to positive infinity and negative infinity as well. Notice my intervals are listing them in numerical order from least to greatest. Okay, so you read left to right. You also want to write your numbers left to right, least to greatest, kind of follow your number line. Okay, the next one is a quadratic function. This is when you have an exponent of 2, that is your leading term. This is going to make a parabola. Okay, this is our parent function. So this is when your parabola vertex is right here at 0, 0. Again, we should have arrows at the ends of our graph. So if this graph continued on forever and ever, okay, and it went on, there are no limits left and right as to where it can extend. So again, we have a domain of negative infinity to positive infinity, or all real numbers. Now the range is a little different, because if you notice, let's go ahead and highlight our y-axis. Okay, and you can see that the lowest it goes is right here. It does not go any lower. So for this function, our range is going to start at 0 and it's going to extend up, but it's going to go forever. So we're going to say infinity. Okay, now we got to figure out the end brackets. So remember, infinity is always open because you can't include infinity. You can always get bigger than infinity or negative infinity. Okay, but the 0 tells me that it is, so we have a dot on 0, it's filled in, which tells us that it is included. So we're going to use the square bracket to tell us that 0 is included in the range, and then it goes up from there. Okay, we could also say for this one that that should be y, that y is greater than or equal to 0. Depending on what form they ask it for. This is the, you have interval form, and then you have an inequality. Okay, and then the last one we're going to look at for this is the cubic function. And here we have a leading term of an exponent with 3. It gives us this curve, okay? Again, I'm going to go ahead and make a note for myself that we have arrows at both ends. There's no restrictions. Okay, and so my domain left to right, if this continued, it could go all the way out to infinity. And then also to, or sorry, negative infinity. And then to the right, it could also go to positive infinity, which we know this is also all real numbers. So left to right. Okay. And then our range is up and down. Okay, so going up, there's no limit, and going down, there's no limit. It continues forever. Okay, so that is domain and range. Be careful when you are looking at other types of functions. We're going to look at some different examples for your CYUs. And then when you get to your lesson check, there will be some different examples there as well. So make sure that you are reviewing what we talked about with the interval lesson, open circle, closed circle, if it's included, if it's not included. Okay. Next part of this lesson, we're going to talk about intercepts. Okay, and we have 2 of those. So our x-intercept is where the graph crosses the x-axis. Okay, which means our y value has to equal 0 in our equation. Okay, x-intercepts are also called roots and zeros and solutions. Okay, all of those count. They're all talking about the same thing, which is where the graph is going to cross the x-axis. Y-intercept is where the graph crosses the y-axis. So this is where x equals 0. Okay, there's a couple ways to find these. So first, you can use a graph. So you can graph your equation and see where it crosses. Sometimes this gives you an integer and sometimes it doesn't. So this isn't always the most effective way if it's not an integer answer for your intercepts. Okay, so for this first one, we're going to look at the linear function, parent function y equals x. And my x-intercept, I only have 1. It's right here. Okay, and it is going through 0, 0. Now, to check that algebraically, we know the x-intercept has a y value of 0. So if I substitute, then I would say 0 equals x, which becomes my x-intercept. So I have an x-intercept at x equals 0. Okay, y-intercept, we're going to plug in 0 for x, so that tells me that y is 0. Okay, if you have an equation that is not the parent function, make sure you follow PEMDAS rules to simplify. Okay, so again, my y-axis is here, and I can see that it's crossing at x equals 0. Y equals 0, sorry. Okay, so x-intercept, y-intercept. Hopefully this is review, guys, and you will have some more challenging problems on your CYUs, which I'll give you the answer key, and then you'll do a lesson check to make sure we can apply it to different scenarios. Okay, quadratic function, y equals 0 squared. Okay, so let's go ahead and do this algebraically first, because this is what I'm going to want to see on your paper, and then we will verify it on the graph. Okay, so x-intercept means I'm plugging 0 in for y. So for this one, I would have 0 equals x squared. Okay, and I'm going to go ahead and write out the steps so that we can walk through it together. In order to undo the x squared, we're going to take a square root of both sides. The square root of 0 is 0, and the square root of x squared is x. Okay, and so here I have an x-intercept at x equals 0. Do I cross the x-axis at 0? I sure do. Okay, the y-intercept is where x equals 0, so this is going to be y equals 0 squared, and we know that 0 squared equals 0. So I have a y-intercept at y equals 0. Check my y-axis, and yes, I do cross over the y-axis at 0. If it helps to highlight them, you can use 2 different colors. Highlight your axis and then look at where the graph is crossing to verify your answer. The last one here is your cubic function. So this one, same idea. For x-intercept, we're going to plug in 0 for y. So 0 equals x cubed, and we know 0 to any power is going to equal 0, so x is also going to equal 0. To do the inverse operations, we're going to take the cubed root of both sides. Okay, sorry, didn't mean to skip that. Okay, so x equals 0. So I'm checking my x-axis here. I can go ahead and this is nice. Let me show you. I can use the line tool in Cami to mark my x-axis, and I can see that yes, it does look like it crosses at x equals 0 to verify my algebra steps. Okay, and then y-intercept is where x equals 0, so y equals 0 cubed, so y equals 0. And then to verify that one, we'll go ahead and use a different color. Not the same color as the graph though. So do a vertical line. This is my y-axis, and yes, it does look like I'm crossing right there at y equals 0. Okay, that's your lesson. Go ahead and do the check your understandings. Let me know if you have any questions. When you're comfortable with this, you can move on.